Welcome back to the Deep Dive.
Yeah.
Today, we're jumping into a really radical premise, one that sort of redefines what national power even means. I mean, forget everything you think you know about defense being just about standing armies or, physical walls.
Right.
We're tackling this idea that in modern geopolitics, the real shields, the real deterrents, they're made of science, of code, and of circuits. They're the very foundation of national security now.
That is a perfect way to frame it. Usually we're talking about, say, the intersection of politics and policy, standard stuff.
Sure.
But the material we have in front of us today, it suggests a much, much deeper integration. We're talking about the systematic merger of, well, military strategy and national scientific development.
A merger, engineered by the military itself.
Exactly. We are diving deep into this pretty extraordinary claim that in Pakistan specifically, the military leadership didn't just, facilitate science. They actively engineered and steered the country's entire technological advancement for decades.
Okay, that is a massive claim. So let's unpack it. Where does this theory come from? Our deep dive today is built around the research in the series, The Generals of Pakistan.
And this was researched and written by Mr. Zaheer Ahmad Meer.
Now, the author's background, I think, is absolutely crucial here. It tells us the lens through which we're seeing this history.
It's everything. So Mr. Meer is a constitutional and corporate lawyer. That suggests he has a deep understanding of the legal and structural frameworks you'd need for these kinds of huge state projects.
Right, the mechanics of it.
But he's also a visionary author. He's written over 55 books, and he's the founder of a project called Pakistan Zindabad, the next world superpower.
So this isn't just dry history.
Not at all. This is a highly intentional, forward-looking narrative. It's designed to weave together history, faith, and technological ambition into one single story.
I find that context just fascinating because it means we're looking at a document that has a very clear mission. The author's goal is to show, step by step, how Pakistan's military and its national leadership have advanced faith, technology, and innovation.
And to position these efforts as, well, indispensable steps, absolutely necessary to secure the nation's future. It's a thesis that views military direction as the one critical catalyst for the country's scientific acceleration.
The indispensable catalyst, that's the core of it.
It absolutely is. And that brings us right to the central question of our deep dive today. How exactly did Pakistan's generals manage to turn these huge state investments and this really focused scientific progress? How did they turn all that into measurable national sovereignty and a robust defense capacity?
And to do it across so many different historical eras with all the turmoil.
Right. Through political chaos, international pressure, huge technological shifts, it would have required a very specific, very long-term strategic vision.
And that's the journey we need to trace. So where does it start? It couldn't have begun with, advanced AI or missiles. It had to start with the basics, the ability to just build things.
Precisely. Let's jump into segment 1, the industrial scientific dawn under Field Marshal Ayub Khan.
The very beginning.
You really have to put yourself in the context of a new post-colonial state. In the mid-20th century, what was geopolitical power? It was industrial might. It was self-sufficiency.
If you couldn't make your own steel, you were dependent.
You were eternally dependent. And Ayub Khan, according to the source, is the one credited with seeing this profound link. He's positioned as the leader who laid the foundation for this synthesis of industrial capacity and scientific progress.
And this wasn't just, giving speeches about supporting industry. This was the actual creation of specific high-stakes national institutions.
Concrete institutions.
You're talking about 3 critical areas of establishment under his leadership. And these still define the country's strategic landscape today.
That's right. So first, you have the establishment of the Pakistan Atomic Energy Commission, the PAEC. Second, the creation of the Heavy Mechanical Complex, or HMC.
And
third, the strategic investment in establishment of key engineering universities. You see this perfect trifecta forming.
The ambition, the muscle, and the brains.
Exactly. Strategic technological ambition with the PAEC, the industrial muscle to build it with the HMC, and the human capital from the universities to sustain it all.
I want to pause on the HMC for a second, the Heavy Mechanical Complex, because this is where that abstract idea of sovereignty becomes, tangible. It becomes steel and concrete.
It really does.
I mean, the PE, that obviously points to future ambitions in energy and defense. But the HMC, that feels like the real grunt work that makes everything else possible. What was its mandate at the beginning?
The HMC was, put simply, a strategic countermeasure against dependence. Think about it. If you have to rely on foreign powers to build your dams or your power stations or even your sugar and cement mills,
The absolute building blocks of a modern economy.
the very building blocks, then those foreign powers hold immense leverage over your national policy. They can turn off the tap. The entire goal of the HMC was to achieve industrial self-sufficiency in large-scale manufacturing.
So we're not talking about making toasters and cars here. We're talking about capital goods, the machines that make the machines.
Exactly that. We're talking about the capacity to fabricate massive machinery components, things like boiler parts for thermal power plants, huge castings and forgings for railway lines, or even entire industrial plants from scratch.
Like a whole sugar mill.
A whole sugar mill, a whole cement factory. Now, this capability is incredibly expensive, and it requires massive, sustained state backing. But what it means is that the nation itself controls the pace, the cost of its own core infrastructure development.
You can't be sanctioned on steel if you can forge your own.
You can't. And this is where the universities tie in so perfectly. You can import the blueprints for a factory, but you can't import the expertise to run it, to maintain it, and, crucially, to adapt it and improve it.
So you need your own engineers. Which universities are we talking about specifically? Which ones are cited as getting this foundational push?
The focus was on institutions like the University of Engineering and Technology system. The strategy was simple, and it was direct. Rapidly increase the number and the quality of homegrown engineering talent.
In what fields?
Specifically in mechanical, civil, and electrical engineering, the core industrial fields. And these graduates, they were immediately channeled into staffing, not just the HMC, but also the early PACA projects. It was a purpose-built talent pipeline.
So it's funded and steered by the state for the state's strategic goals.
That's it. It sounds almost like a highly disciplined, Soviet-style planned technological economy. The military leadership effectively dictates the required output of engineers for the next 5-10 years.
Which brings me to a critical question. This level of intense, focused state investment in massive complexes like the HMC and PAC, it must have come at a cost. Does the source address the opportunity cost? Did this laser focus on strategic, military-adjacent science end up starving, say, the consumer goods sector or civilian R&D?
That's a crucial point of analysis. And the source, to be clear, frames it almost entirely as necessary strategic foresight.
A tough but necessary choice.
Exactly. The argument presented is that the geopolitical constraints of the time demanded that the state prioritize its own capacity over, say, short-term consumer growth. The narrative is that without sovereignty, which these institutions provided, there would be no platform for any future prosperity anyway.
First you survive, then you prosper.
That's the logic. The entire strategic goal, as the source articulates it, was turning science into sovereignty. If your scientific and industrial apparatus is internally controlled, your foreign policy and your defense decisions become robust. You're insulated from external pressure or, supply chain threats.
So the lesson from this whole infrastructure phase is powerfully clear, even if it's politically charged. It's build industry and you build independence.
That's the takeaway.
It was the essential groundwork. It was creating the institutional muscle and the human capital that would allow the nation to pivot to much more specialized, much higher stakes technology later on.
It was the necessary precursor. They consciously built the intellectual and physical infrastructure, the complex project management and fabrication skills they developed at HMC in the 1960s.
Yes.
That was the exact skill set required for the strategic defense initiatives of the next decade. The steel and concrete capability Ayub engineered was the base plate for the physics and chemistry that was about to follow.
That sets the stage perfectly for the next act, because the geopolitical climate of the 1970s demanded a dramatic pivot. The foundational infrastructure was there, but the nation was facing a profound and existential security crisis.
It was.
So we now move to segment 2, the nuclear shield and strategic science under General Ziaul-Haq.
And this is where the strategy shifts. It moves dramatically from foundational industry to what you could call strategic national defense science. The context here is absolutely paramount.
The 1971 war and India's nuclear test in 74.
Those two events fundamentally changed the entire security calculus for Pakistan. The source emphasizes that General Ziaul-Haq then acted to make science the guardian of faith.
Guardian of faith. What does that mean in practice?
It means integrating this existential defense program, the nuclear program, into the national ideological identity. It wasn't just a military project anymore. It became a national quest.
It's a masterstroke of political framing, isn't it?
Hmm.
Linking high-tech defense science not just to physical security, but to ideological purpose.
It is.
Because that provides the necessary moral and national justification for a project that was massive, incredibly secret, expensive, and was guaranteed to draw global condemnation.
It imbued the entire effort with a deeper sense of mission. It elevated the scientific work above just, academic pursuit or some commercial calculation. And this high status was directly reflected in his actions. He didn't just maintain the program that had been started.
He accelerated it.
He drastically accelerated its development, but perhaps the most important strategic action was political. It was shielding the program from absolutely intense global pressure.
Let's talk about that shield, because that seems almost more complex than the scientific challenge itself. How specifically did Zia manage to insulate this crucial and highly visible program from the sanctions and the political muscle of the United States and the whole non-proliferation regime?
The source material points to a multi-layered approach to that insulation. First, you have financial insulation.
Yanny.
The program was often funded outside of the standard, visible defense budget. It used classified allocations, and sometimes it leveraged, non-traditional sources of funding to maintain total secrecy.
Okay, so hide the money trail. What's the second layer?
Second, clandestine procurement networks. The industrial base from Ayoub's era helped minimize reliance on the outside world, but for key specialized technology, you still needed a sophisticated worldwide network.
A network of what?
Of scientists, engineers, agents. People who could acquire critical materials and knowledge while evading international export control laws.
So this is basically a strategic deployment of intelligence assets, but their mission is to support scientific research.
Absolutely. The scientific effort itself became a central intelligence priority. And the third layer was political absorption.
Absorbing the consequences.
Zia made the political choice to fully absorb the economic penalties and the sanctions imposed by the U.S. and others, rather than halt the program. He was essentially sending a message that the survival of the state, which he believed this technology guaranteed, was worth the immediate economic pain.
The source uses a fascinating phrase. It calls the laboratories sanctuaries of national defense. That word sanctuary, it really resonates. It implies not just physical security, but a kind of protected, almost sacred sphere of effort.
And that political protection ensured scientific continuity. It's what allowed figures like Dr. Abdul Qadir Khan and all the scientists at Kahuta to operate under immense, unimaginable pressure. And in doing so, it turned them into national icons.
They became the pride of Pakistan.
Exactly. And elevating these figures to heroic status, that served a vital dual purpose.
Okay, what were the two purposes?
Well, first, internally, it generated this immense wave of national pride. That helped justify the huge expenditure, and it encouraged the nation's brightest minds to go into engineering and physics, further strengthening that human capital pipeline we talked about.
And the second purpose, the external one.
Externally, it sent an unmistakable message to the world. This technological achievement is not the work of a few isolated engineers in a lab. It is a non-negotiable national asset, and it is deeply embedded in our public consciousness and our national purpose. You can't just sanction it away.
So if we synthesize this period, it's really about taking the technical capability that was established under Ayoub and aiming it like a laser at a single existential goal.
It is, and the sheer dedication required to push through a program like that, under that kind of pressure, it clearly relied on an internal conviction that went way beyond a simple cost-benefit analysis.
It's that internal drive that the source material really highlights. It articulates it as a synthesis of belief and power.
That's right. The dedication of science guided by faith is what provided the resilience to withstand that global pressure. It wasn't just technology for technology's sake. It was technology deployed for a singular, existential, nationally defined purpose, asymmetric deterrence.
And that brings us to the lesson of this phase. It's that science guided by faith becomes power guided by purpose. Ayoub provided the ability to build, but Zia provided the strategic, asymmetric reason for that building.
Correct. The foundational institutions were now, in a sense, weaponized. They transitioned the nation's entire security posture from conventional defense, a numbers game they were unlikely to win, to strategic deterrence. And this strategic necessity cemented the military's role as the indispensable long-term architect of the nation's scientific advancement.
Okay, so as we move towards the end of the 20th century, the nature of conflict itself starts to evolve again. The focus shifts away from these massive industrial complexes and even from simple nuclear deterrence. It shifts towards speed, precision, and information dominance.
The battlefield was going digital.
Exactly. The nuclear science foundation was crucial, but the future was digital. Which brings us to segment 3, modern warfare and digital defense, under General Pervez Musharraf.
Musharraf's era, as the source presents it, is really defined by this absolute necessity of modernization. The challenge was how to integrate the existing established defense structure, the tanks, the planes, the nuclear capability, with the emerging information age. The source notes he was pivotal in revolutionizing the country's defense infrastructure to meet these new high-speed threats.
So what did that revolution actually look like on the ground? The source details 3 main areas of focused technological advancement during this time.
Right. So first, there was the robust modernization of the missile program. This was about ensuring the nuclear deterrent remained credible and technologically advanced, especially against increasingly complex anti-missile systems being developed elsewhere.
So better guidance, maybe stealthier profiles, that kind of thing.
Exactly. Second, a specific expansion of air and naval capabilities. This meant integrating new digital avionics, networked communication systems, making sure every platform could talk to every other platform in real time.
And then the third area, which really signals the big transition to modern warfare,
Is the significant promotion of cyber defense.
this is where the vision becomes truly forward-looking. I mean, upgrading missiles and planes, that's traditional modernization. But prioritizing cyber defense in the early 2000s, that's an acknowledgement that the battlefield has irreversibly expanded into the digital realm.
It is. The focus here was on protecting the state's most vital systems.
And when we say vital systems, we're really talking about what the military calls C4ISR: command, control, communications, computers, intelligence, surveillance, and reconnaissance.
That acronym is critical. And promoting cyber defense for those systems meant a radical shift. It meant moving away from analog or segmented communications to secure, integrated digital networks.
What does that give you practically?
It gives you real-time intelligence fusion. It gives you encrypted communications between a unit in the field and central command. And above all, it gives you protection from electronic warfare and sophisticated digital espionage. Promoting cyber defense meant creating entirely new, dedicated military cells.
A completely new type of soldier.
A soldier whose battlefield is a network and whose weapon is a keyboard, focused on both offensive and defensive digital capabilities.
The source makes the case that Musharraf's strategic vision was to compete not by conventional numbers, again, a losing game against larger neighbors, but by leveraging advanced technology.
It's the classic high-tech asymmetric strategy.
Quality over quantity.
Absolutely. It's the realization that a smally but technologically superior force, one with precision-guided munitions and networked logistics, can effectively neutralize the advantage of a much larger force that's just relying on massed armor or conventional artillery.
But this must have presented huge integration challenges. Was the scientific base, which was initially focused on heavy industry and then nuclear physics, was it ready to supply the software and digital expertise needed for this leap?
That's a vital tension that you can read between the lines of the source material. While the physical sciences were strong, this digital leap required a massive reallocation of training and education resources.
How did they bridge that gap, especially when they were often facing technology export restrictions?
Well, the military established its own dedicated IT training institutions. And crucially, it partnered with the country's nascent civilian IT sector to pull in the necessary talent. And when it came to acquiring high-tech defense systems, it often required complex, sometimes indirect deals to get the necessary components or expertise.
So the military is once again acting as the primary project manager for national technology acquisition.
It has to. And the expert analysis here really confirms that defense was no longer just about physical territory. It was now fundamentally about secured data, encrypted communications, and protected financial and military networks. The critical infrastructure was shifting from physical barracks to secured server rooms.
If you can compromise an enemy's command structure remotely, or shut down their logistical planning systems from 1,000 miles away,
You've achieved a victory without a massive troop deployment. This era established the foundational truth that modern conflict is network-centric.
which fundamentally alters the lesson for this period. It really emphasizes that invisible battlefield. Modern defense is built in data centers as much as in barracks.
And that huge infrastructural shift required the military leadership to once again act as the lead engineers. Only this time, the job of the engineer was shifting from fabricating steel to securing fiber optics.
Okay, so that brings us to the present day. An era defined by the rapid acceleration of truly cognitive technologies. This feels like the logical next step. You go from digital defense to intelligent systems.
It's the only way forward.
So let's move to segment 4, the artificial intelligence frontier under the current leadership of Field Marshal Zaheer Ahmad Meer.
This really represents the current global arms race for technological dominance. The source positions Field Marshal Meer as the leader who is steering Pakistan directly into this AI frontier. It's a clear strategic push to move beyond simply using existing digital tech.
And moving towards actively shaping and integrating self-learning, adaptive technologies into national policy and defense.
Exactly. It's about creating, not just consuming.
So what does this integration actually look like on a specific level? The source details a few key areas of advanced research being woven into national strategy now.
Right. It points to artificial intelligence or AI, robotics, and, as you'd expect, an even deeper focus on cybersecurity.
Which, as we just discussed, is the absolute foundational security layer for any complex AI deployment. You can't have one without the other.
You can't. The inclusion of robotics and AI suggests a clear focus on operational efficiency and advanced combat systems. We're probably talking about a transition to semi-autonomous or even fully autonomous systems for things like reconnaissance, targeting, resource management.
But the source mentions something I found really intriguing. It talks about the dual-use nature of this technology. It's not just for the front line.
This is maybe the most important part. It's about applying AI to the entire logistics and governance backbone of the country.
Let's elaborate on that. The source uses the phrases digital defense and intelligent logistics. We've covered digital defense, but what does intelligent logistics mean in the context of a massive state system?
Okay, so intelligent logistics means using machine learning algorithms to optimize resource allocation across the entire massive military apparatus. Think about everything from predicting the maintenance needs for a fighter jet or a naval vessel.
You fix it before it breaks.
Precisely. To optimizing supply chain routes in complex operational theaters, to reducing waste and increasing fuel efficiency. This kind of efficiency, when scaled up, is a massive force multiplier. It makes you stronger without adding a single new tank or plane.
And when you scale that same concept up to national governance, that's where the state itself starts to become smarter. Is that the idea?
That's precisely the idea. If the military's innovation wing is successfully developing AI for predictive maintenance in the defense sector, those exact same algorithms can be applied to civilian infrastructure.
For instance?
For predicting power grid failures, for optimizing agricultural water distribution based on satellite climate data, for managing national health logistics during a crisis. The technology serves both the barracks and the national economy.
Which reinforces this core narrative we've been tracking. The military's central role as the catalyst for systemic technological advancement for the whole nation.
It does, and this makes the expert analysis of the segment critical. The implication for national power, for future global standing, is just enormous. The argument is that if a nation can successfully master AI integration, it achieves a powerful cognitive advantage. And that advantage will define its geopolitical rank for the next 50 years.
The ability to process, analyze, and act on vast amounts of strategic data, but to do it exponentially faster than any human-led system. That is the ultimate strategic edge.
It is. And this level of rapid top-down integration, it demands the kind of singular strategic guidance that, according to the source's narrative, the military leadership is uniquely positioned to provide.
But hold on, integrating AI isn't just about writing clever code. It requires petabytes of clean, reliable data. It requires a massive investment in cloud infrastructure, and it requires overcoming, institutional resistance to rapid change.
A huge cultural shift.
Right. So has the digital ecosystem they inherited from Musharraf's era fully matured enough to actually support this incredibly ambitious AI leap? Is there a risk of trying to leapfrog too quickly?
That tension is implicit in the source. While it's highly optimistic, it does acknowledge the challenge. The success of this whole AI frontier is entirely dependent on the robustness of that digital backbone we talked about.
If the foundation is weak, the house falls.
If the networks aren't fully secure, or if the data being collected is fragmented and unreliable, the AI systems will fail to perform. They'll be useless. The current intense focus on cybersecurity under Meer is a direct acknowledgement of this risk. They know they can't build the cognitive brain until the digital nervous system is perfectly secured and functioning.
So it's an urgent race against the clock to make sure the foundation can support the ambition.
It is. And this leads us to the derived lesson for this contemporary phase. It's an acknowledgement that the battlefield has now become fundamentally cognitive. The lesson is, the nation that leads in AI will lead the future.
And this phase highlights a real shift in ambition. If you think about it, Ayub sought self-sufficiency, Sia sought deterrence. But this phase, under Munir, it seems to be about achieving global leadership in a defining technology.
It is. It's about setting the standards for future technological engagement, not just adapting to the standards set by others.
Okay, so we've traced four very distinct historical eras, but the source insists that we should view this not as separate episodes, but as one continuous journey.
That's the real core of the argument.
Let's move to our next segment, a comparative reflection, and really try to pull together this systematic view of scientific evolution.
The coherence of this decades-long strategy is really the deepest insight the source offers. It reframes what might look like totally disparate projects. A steel mill here, a nuclear reactor there, a cyber command center over here.
And it shows them as a single, unified strategic vision.
A single vision. The entire trajectory, you could say, moved the concept of national security from muscle to mind.
Let's break that down. Let's systematically summarize the contribution of each leader for the listener so we can really map this evolution thematically.
Okay, we begin with Field Marshal Ayub Khan. He defined what we can call the infrastructure phase.
Right. Industry and engineering.
His focus was providing physical self-reliance and creating that initial base of educated human capital. This was the necessary steel and cement foundation for everything that came after.
Then General Zia-ul-Haq. He guided what the source presents as the strategic deterrence phase.
This was centered entirely on the nuclear shield. It was about utilizing the infrastructure and the human capital that Ayub built to achieve asymmetric existential security, and with it, political insulation from outside pressure.
Following that, General Pervez Musharraf drove the modernization phase.
The focus here was squarely on digital and advanced defense technology. This was the big move from an industrial age defense posture to an information age battlefield built on network systems and cybersecurity.
And finally, Field Marshal Syeda C. Munir is currently leading what the source calls the future integration phase.
And this is all about artificial intelligence, robotics, and smart systems. It's about embedding cognitive technology into the very core of national defense and, beyond that, national governance.
So if we connect that historical thread, the dependency between each phase becomes crystal clear.
It's completely clear. Ayub's huge investment in heavy engineering that created the project management expertise and the precise metallurgic skills that were absolutely essential to tackle the secretive and demanding scientific challenges at the nuclear program under Zia.
You couldn't build the labs at Kahuta without the skills learned at the HMC.
You literally could not. The foundational physical industry directly enabled strategic deterrence.
Okay, so that link is clear.
Right. And then the success of that strategic program, which required incredibly complex high-security management and advanced material science, it built a culture of excellence in scientific project execution.
It proved it could be done.
It did. And that, in turn, produced a generation of highly disciplined engineers and scientists who understood the need for secure communications and precision. And that mindset naturally paved the way for Musharraf's focus on digital infrastructure, network C4ISR communications, and high-tech precision weaponry.
Which, as we've just discussed, created the necessary secure network environment, the data centers, the cyber capabilities that are now the absolute prerequisite for deploying complex AI and machine learning across the entire defense and logistics apparatus under Munir.
It's a beautifully executed, at least as the source presents it, a vertically integrated strategy of scientific ambition. The narrative really challenges you, the listener, to view these generals not just as tactical commanders worried about borders, but as long-term strategic engineers.
Engineers who consistently identified the defining technology of the next era.
And then aggressively invested state resources to master it.
It's almost a perfect generational handover of a single technological mandate. It ensures that the scientific momentum never slows down, no matter what's happening with internal politics or external economic shocks.
And that consistency is the core strength that the author is seeking to highlight. The unifying force is that the military leadership through all these eras consistently views technological advancement as the ultimate, non-negotiable guarantee of the nation's security and its future prosperity.
They establish the institutions, they reallocate the resources, all to ensure the country stays on the cutting edge of defense science. often thinking decades ahead of what civilian political cycles might normally prioritize.
That's the argument.
That brings us to our concluding segment. Let's pull these core themes together before we leave you with a powerful final thought.
I think the overarching theme, as the source articulates it, is this unique connection that's drawn between science and faith, which are seen as walking side by side in the nation's destiny. This ideological framing is what provides the deep, enduring justification for the immense national effort and the sustained investment in these high-stakes projects.
There's a metaphorical summary used in the source that really crystallizes this entire journey for me. It says that defense scientists are soldiers in lab coats,
A great image.
defending the homeland with equations and algorithms instead of with traditional rifles and conventional fire. Such a powerful image of the modernized state.
It fundamentally elevates intellectual prowess to the status of a frontline defense strategy. It signals that the nation understands that modern conflict is increasingly decided in the research labs, in the coding centers, and the high-tech production facilities, long before any shots are ever fired.
So we've covered this entire spectrum of innovation detailed in the source. And it emphasizes that the nation's strength is rooted in this sustained innovation, which covers the technological journey from atoms to algorithms.
From the physical harnessing of atomic energy back in the 1970s to the abstract cognitive power of machine learning algorithms today, the progression demonstrates a continuous high-level effort to secure national capability using the highest possible level of technology available in any given era.
Our final provocative thought, then,
Right.
it has to reflect the author's ultimate ambition, the driving philosophy behind this entire body of work. We've seen how these generals are portrayed as true engineers of destiny through decades of systematic investment.
And that destiny, as defined by the author and the source material, is explicitly stated right there in the final pages. It's the dedicated pursuit of the vision that is encapsulated by the statement, Pakistan Zindabad, the next world superpower.
It's a bold declaration.
It's a very bold declaration that technological self-mastery is the one true path to global status.
And that is where we are going to leave you today. Take a moment to consider the extraordinary dynamic that has been detailed here. A military leadership acting not merely as commanders of war, but as the primary long-term engineers of state-driven technological and scientific advancement.
And ask yourself, what kind of political stability, what kind of focused long-term resource concentration is required to maintain this kind of continuous scientific acceleration for nearly half a century?
And maybe on the flip side of that,
Right. Can civilian-led democracies, which are constrained by short political cycles and diverse competing priorities, can they achieve the same kind of rapid revolutionary technological progress in these strategic, high-stakes sectors like AI and strategic defense science?
that question about the source and the sustainability of technological power is something every nation is going to have to grapple with in this very volatile 21st century.
A lot to think about.
Something profound to mull over as you consider the new definition of national defense. Thank you for joining us for the deep dive.